Hello and welcome to another Common Core Geometry video by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit number 6, Lesson number 6 on the rhombus. Unit 6 is all about quadrilaterals, and rhombuses, or rhombi, are just one more type of them. Okay, and what we're going to be doing today is we're going to be looking at their definition and then what properties come from that definition. So let's jump right into what a rhombus is. All right. A rhombus is any quadrilateral, any four-sided figure, with all four sides being equal length, or four congruent sides. So, here we've got a very typical rhombus. All four sides are the same length. Now, if I ask a lot of students, to tell me what a four-sided figure is, where all four sides are the same length, they're going to say a square, all right? And that makes a lot of sense because, quite frankly, a square does have four sides of equal length. The key is that the square has an additional property that the general rhombus doesn't, which is, if I can get it to show up somewhere, there it is. It's also got four right angles as well as four equal sides. Our next lesson is going to be all about squares, and they are the most important, well, maybe not most important, but they're the most special of all the quadrilaterals. They have the most properties. Today, though, we're going to be looking at quadrilaterals that have all four sides the same length, and then what comes from that. So let's take a look at the first ramification, all right? And what we're going to be doing in exercise 1 is we're going to be justifying the fact that all rhombuses, all rhombi, are also parallelograms. Okay? So a rhombus is a special type of parallelogram, which is probably pretty obvious from simply its picture, but we're going to prove that in exercise 1. So let me read it through for you. Exercise number 1. Given that ABCD is a rhombus with diagonal BD drawn, letter A asks us, why must triangle ABD be congruent to triangle CDB? All right? So why does the triangle up here have to be congruent to the one down there? Remember, we're talking about a rhombus here, okay? And what I'd like you to do is pause the video right now and think about why that must be. Then what I'm going to do is I'm going to lay out a very, very short paragraph proof, not a T-table proof, about why those two triangles are congruent. But see if you can figure out. All right, let's talk about it. Well, let's see what we know. Now again, I'm trying to prove that this triangle is congruent to this one down here. And because it's a rhombus, what I know is that all four sides are the same length, right? I know that, okay? But what I also know about these two triangles is that they share a side. They share side BD. So now think about this, right? I can say that AB is congruent to CD. So this one's congruent to this one. And AD is congruent to BC. These two, because a rhombus has four congruent sides. Well, that's simple enough. But as well, those two triangles share a side. BD is congruent to itself. And if I want, I can just a little reflexive property. Ooh, there's my red. So, triangle ABD must be congruent to triangle CDB by the side theorem. Right? Simple as that. I've got these two triangles, and they're congruent because a side is congruent to a side is congruent to a side, and then they have that shared side, the side theorem. Right? Now, take a look at letter B. Because of A, what can you conclude about angle 1 and angle 2? All right, so let's just bring this up a little bit. Because we know that this triangle is congruent to this triangle, what can we say about those two angles? Well, clearly, we can say that angle 1 is congruent to angle 2 by C, P, C, T, C. I've got way more room here than I need, all right? But this angle and this angle are congruent because corresponding parts of congruent triangles are congruent. All right, great. So think about this now. We've got this rhombus, right? And because it's a rhombus, we can prove that this triangle is congruent to that triangle, which then tells me that this angle is congruent to that angle because they're corresponding parts of congruent triangles, and therefore they must be congruent themselves. And now let's take a look at letter C. Let me extend the page a little bit, and let me mark these two angles as being congruent, right? Letter C now says, based on B, what can you say is true about AB, right? And DC, about AB and DC. What can you say about those two line segments because angle 1 and angle 2 are congruent? Well, you can say that AB is parallel to CD because, oh, my magic red pen is showing up a lot, because alternate interior angles are congruent, right? But further, it then says, why does this allow us to conclude now that ABCD is a parallelogram? So why is it that knowing that we've got a rhombus, that's important, knowing that we've got a rhombus, and knowing just that AB is parallel to CD, why is that enough now to know that this has to also be a parallelogram? Well, there's many, many different ways, remember, to justify that something is a parallelogram. One way is just by using the definition, which is that it's a four-sided figure with opposite sides, both pairs of opposite sides being parallel, all right? But there's other ones, okay? And one of the other ones simply is, since we now have a pair of opposite sides both congruent and parallel, it must be a parallelogram. So do you remember that? There are many different ways to prove something is a parallelogram. One of the ways is by showing that you've got a four-sided figure where the opposite sides, where you've got one pair of opposite sides that are both equal in length and parallel. Now, quite frankly, there's maybe an even easier way to prove that all rhombuses are parallelograms. Because one of the ways that we prove that things are parallelograms is showing that they've got two pairs of opposite sides that are congruent. Well, here's one pair of opposite sides that's congruent, and here's another pair of opposite sides that are congruent. So there's different ways to prove that a rhombus is a parallelogram. In fact, you could basically use almost any method you wanted to, all right? Now, because a rhombus is a parallelogram, it also has all the other properties of parallelograms. Remember, some of those properties are things like opposite angles, didn't mean for that thing to move, opposite angles, right, like angle A and angle C are congruent, adjacent angles like angle A and angle D, assuming that diagonal's there, not there, angle A and angle D are supplementary. Remember, you've got other things like the diagonals bisect each other, they cut each other in half. All of those are important because now that we've proven that all rhombi are also parallelograms, all of the properties of parallelograms kind of come along for the ride, okay? So let's now see where we can go with this. Rhombuses have a lot more about them, all right, that general parallelograms don't have. And it all just comes from the fact that they're parallelograms where all four sides are the same length. And let's start to take a look at those additional properties in exercise number 2. All right, exercise number 2. RSTU is a rhombus with diagonals RT and SU intersecting at W. use tracing paper to carefully trace RWS. So I definitely want to do this along with me, okay? Pause the video right now and trace out, and if you need to, use a ruler, but really carefully trace out this particular triangle, okay? Take a moment to do that. All right, so now what I'd like you to do is I'd like, in letter B, for you to use that traced picture to see of these other 3 triangles that are sitting here, all right, which are congruent to the one that you just traced out. So take that traced out triangle and circle which of those 3 triangles, RWU, TWU, SWT, are congruent to the one in red. Take a moment. All right, well, let's go through it really quick. One thing I can do right away is if I take my triangle and I rotate it by 180 degrees, I can see that it lands right on top of TWU. So that one's definitely congruent to it. But if I do a little reflection, and for you that means that you would have turned your tracing paper over, right? So if you turn your tracing paper over, then what we can see is that it's also congruent to TWS, or SWT as the case is down here, and it's congruent to RWU. So now this is very, very important. Generally speaking, this isn't the case in parallelograms, right? If you've got just some random parallelogram, and you draw in its diagonals, the 4 triangles that are created by drawing in the diagonals are not all congruent to one another, but in a rhombus they are, okay? And we'll prove that in just a moment. But in a rhombus, the diagonals cut up that rhombus into 4 identical triangles, right? All 4 are congruent. That's very, very important to note about rhombuses. All right? So let's go ahead and prove that. Exercise number 3. Given RSTU is a rhombus, prove that RWS, triangle RWS, is congruent to triangle RWU. The proofs of the congruence of all the other triangles are similar. So in other words, I'm just going to prove that this triangle and this triangle are congruent. I could have done this triangle and this triangle, or this triangle and this triangle. It really wouldn't matter. We're just going to prove that those 2 are congruent, and we're going to take it on face value that doing the proofs of the other ones would be more or less identical. So what I'd like you to do, right, and keep in mind that we already know that rhombuses are parallelograms, so you can bring in facts about parallelograms here too, but how would you go about proving that this triangle is congruent to that one? Pause the video now and take a few minutes to think about this. All right, let's go through it. Well, just based on the fact that it's a rhombus, obviously we can say that this side is congruent with this side. All 4 sides of a rhombus are congruent to one another, right? Now, what we also know, and what we should always be looking for, are things like shared sides. So those 2 triangles actually share side RW. All right, now, we don't so much know too much about angles in all of this, okay? So let's see, right now I got a side congruent to a side congruent to a side. All right, if I wanted to use side angle side, I'd have to somehow get this angle congruent to this one, and I don't really have anything in my tool bag right now. But is there any reason that we could say that this side is congruent to that side? And the answer is absolutely, okay? Not so much because we're dealing with a rhombus, but because we're also dealing with a parallelogram. And in a parallelogram, the diagonals bisect each other. Every parallelogram, when you draw in the 2 diagonals, they cut each other in half. So let's lay out the proof. It's not too bad, right? Again, I'm going to kind of do a sort of a mishmash paragraph proof / T-table proof. I'm going to say UR is congruent to SR because all sides of a rhombus are congruent. All right, I can say that RW, get that one down right away, is congruent to itself, RW, and that's just the reflexive property. Okay, and then I can say that UW is congruent to SW, all right, because all, oops, that doesn't look like rhombus at all. Let's try that. All rhombi are parallelograms and the diagonals of parallelograms bisect each other. And so obviously, because of that, we can now say that triangle RWS is congruent to triangle RWU by the side-side-side theorem. Side-side-side theorem is getting a workout today, which isn't overly surprising given the fact that rhombuses have so many sides that are congruent to each other, right? So it's not surprising that side-side-side would come out quite a bit. Anyway, let me just pause though my speaking for a bit. You pause the video as well in case you need to write any of this down. All right, now again, I want you to be very clear about something. We could easily now prove that this triangle is congruent to this triangle. It would be the identical reasoning. We could then prove that this triangle is congruent to this triangle, identical reasoning. We could actually prove that these two triangles are congruent to each other, but they would always be congruent to each other in parallelograms. So sort of the triangles that share those vertical angles in any parallelogram are congruent. The real question is sort of, why are these adjacent triangles congruent? And that is, in these cases, always side-side-side. Now think about this. There's going to be a lot of things that come from the fact that these four triangles are congruent, and they're all going to now hinge on CP-CTC reasoning. So let's take a look at some of those. All right, exercise number 4. Given the diagram above and the proven fact, this is important, that the four triangles are congruent, why can we say that the diagonals are perpendicular? And why can we say that the diagonals bisect the vertex angles? All right, so again, two extremely important properties of rhombuses that general parallelograms don't have. One, the diagonals are perpendicular to each other. They're perpendicular, they form right angles. And two, the diagonals also bisect the angles of the rhombus, right? So let's first talk about perpendicularity. Think about why you can say the diagonals are perpendicular to each other. Take a moment, see if you can frame out an argument. All right, well, let's talk about it. Let's take a look at just these two triangles, okay? And in fact, let me call this angle 1, and let me call this angle 2 down here, right? Well, one thing I can say is well, angle 1 is congruent to angle 2 by CP-CTC. All right, so those are the corresponding angles on these two congruent triangles, right? That proven fact. But if you think about this, right, angle 1 and angle 2 must add up to 180. So angle 1 and angle 2 are supplementary, right? They add up to 180, right? Because this is a straight angle, but that means they both have to be 90 degrees. Right? I don't need them both to be 90 degrees, but I certainly need one of them to be 90 degrees in order to have that perpendicularity. So they both measure 90 degrees. That's it. They both measure 90 degrees. And it's a very important property of rhombuses. The fact that their diagonals form 90-degree angles. They're perpendicular to each other. Again, not generally true of general parallelograms. All right, if I've got that parallelogram and I draw on these two diagonals, it should be fairly obvious that these angles are not 90-degree angles, but these all are. Okay, now the second piece is the fact that the diagonals bisect the angles, right? They bisect the angles of the rhombus. And that's actually pretty easy as well, and here's why. Let me call this angle 3 and this angle 4. There we go, angle 3 and angle 4. Well, again, just like before, angle 3 must be congruent to angle 4 by CP/CTC. Now, even easier, if angle 3 is congruent to angle 4, well then, by definition, that angle has been bisected. Angle RUT has been bisected by SU. Let's kind of put that down. Actually, we'll just do, we'll go SU. SU bisects angle RUT by the definition. By the definition of an angle bisector. All right. Now these two properties, the perpendicularity of the diagonals and the fact that they bisect the angles of the rhombus, are things that you're going to want to memorize. One thing that's a little bit helpful is to realize, and I'm going to bring this out for a second, is to realize that what you've really got in those two right triangles is you've got an isosceles triangle. That's really it, right? You've got an isosceles triangle, and this simply is that altitude that divides that isosceles triangle into two congruent right triangles. All right, and it's helpful to be able to visualize that with rhombuses. Okay. Let me kind of step out of the way for a moment, and then we'll move on and do another problem. Okay. Now, due to the special properties that rhombuses have, it's easy to kind of create problems that force you to use those properties, and this is a really good example of one. Exercise number 5. If a rhombus has diagonals of length 10 and 24, what is the perimeter of the rhombus? In other words, what's the distance all the way around the rhombus? So let's take a look at this. Let's draw out a picture and see if we can get a sense for what's going on here. Right now, I want to try to make my picture sort of as realistic as possible. So I'm going to draw something that I try to make it look like all four sides are the same length. But I'm not going to draw it like it's a square. That could be deceptive. Okay, I'm going to draw my two diagonals in. And I know the shorter one has a length of 10, and the longer one has a length of 24. Okay, and I want to figure out what the perimeter of the rhombus is. Now keep in mind, perimeter we find by just adding up the lengths of all four sides of this rhombus. Since all four sides are the same length, if I can figure out the length of one side, I've got them all. Well, one of the keys here is that I know that that is a 90-degree angle. That's one of the properties of a rhombus. And because a rhombus is a parallelogram, these diagonals bisect each other. In other words, this would have a length of 5 and 5, and this would have a length of 12 and 12. And the beautiful thing here is that now we have these four right triangles. They're all congruent. And let me kind of break one of them out here. Right? And they all basically look like this. Right? They're four congruent right triangles. And I need to find the length of their hypotenuses. Hypotenuse? Probably not. Hypotenuses. All right? So take a moment. I'm going to call it C. And try to solve for C using the Pythagorean theorem. All right, let's go through it. Some of you are probably well versed enough in the Pythagorean theorem at this point to even know what the C would be. But let's work through it anyway. All right, 5 squared plus 12 squared equals C squared. 25 plus 144 is C squared. That'll be 169 is C squared. Take the square root of both sides. And C ends up being 13. Now watch out, because that's not the perimeter. That's simply the length of each one of the sides. You can now find the perimeter either by just doing 4 times 13 or by adding all 4 13s up. Either way, the perimeter will be 52. All right, this is a classic rhombus problem because you have to know that the diagonals are perpendicular, and you have to know, because it's a parallelogram, that the diagonals also bisect each other. All right, so let's keep moving on. One last problem. Okay, let's take a look, multiple choice. Given that ABCD is a rhombus with the measure of angle CBD is 67 degrees, then which of the following is the measure of angle BAD? All right, take a few minutes and see if you can figure out what the right choice is. All right, let's go through it. There are tons of different ways to do this problem, and it's kind of cool in that sense, right? First, let's make sure we know which angle we're looking for. We're trying to figure out the measure of angle BAD, also known as angle A, okay? That's the one we're looking for. We just have to get over there. So what can we do with that 67? Well, one thing we can do, we know that the diagonals of a rhombus bisect the four angles, which means if this is 67 degrees, this is also 67 degrees. All right, that's what it means for the diagonals to bisect it. Now, keep in mind, of course, that these two sides are congruent, and so that this triangle and this one, but I'm really kind of concerned about this one, is an isosceles triangle. The two triangles are isosceles triangles, but this one is an isosceles triangle, which means that the two angles opposite the equal sides have to be equal in measure. So that also has to be 67 degrees. Now you could say, well, I know that one was 67 because that's an alternate interior angle with that 67, and that would be awesome, okay? That's based on the fact that it's a parallelogram. Based on the fact that this thing is an isosceles triangle, I can say those two are also 67. Now, of course, I think this is pretty clear cut. I'll now take those two 67s and I'll add them together and get 134 degrees. All right, and because all the angles in a triangle must add up to 180 degrees, I'll just subtract off that 134, and I'll find an angle of 46 degrees. All right, simple enough. Take a moment, write down anything you need to, and then we'll wrap up the lesson. All right, let's do it. So in today's lesson, what we did is we looked at the properties of a rhombus, and specifically the properties that come from a rhombus based on its definition. Keep in mind that the definition of a rhombus is any four-sided figure where all four sides are the same length. And what we saw from that is that first and foremost, a rhombus is also a parallelogram and thus has all the properties of a parallelogram. But it's also got additional properties that are specific to the rhombus. The two most important being that the diagonals are perpendicular to one another and the diagonals bisect the angles of a rhombus. All right, we're going to look at that even more in the next lesson as we examine squares, our final quadrilateral. For now, I'd like to thank you for joining me for another Common Core geometry lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.